Have you ever pondered the labyrinthine intricacies of quantum mechanics, or been captivated by the enigmatic concept of micro-wormholes? Well, today we delve into a fascinating roadmap to developing a theoretical and experimental framework using quantum mechanics and the modified Einstein's equation, MEQ. The journey begins with the development of quantum micro-wormhole theory. Here, the focus lies in modeling micro-wormholes using quantum field theory and general relativity. The MEQ serves as the mathematical foundation for modeling the geometry of these enigmatic entities. The idea is to develop quantum models for micro-wormholes, taking into account their topology, geometry, and energy conditions. This stage also involves a thorough stability analysis of micro-wormholes, taking into consideration quantum fluctuations, energy conservation, and exotic matter. The next stage is the detection of these quantum micro-wormholes. This involves the creation of quantum detection algorithms using the MEQ to detect micro-wormholes based on gravitational effects, energy signatures, and space-time curvature. To achieve this, there is a need to design and optimize quantum sensors that can effectively detect these micro-wormholes. The third stage is the manipulation of these quantum micro-wormholes. Techniques and methods are developed to open micro-wormholes, considering the energy requirements, exotic matter, and space-time manipulation. The stabilization of these micro-wormholes is also a critical aspect, which involves energy conservation, exotic matter manipulation, and gravitational effects. The penultimate stage involves exploring the applications of these quantum micro-wormholes. This includes the development of quantum communication protocols through micro-wormholes, taking into account entanglement, teleportation, and information transfer. It also involves developing quantum methods for exploration through these micro-wormholes, considering spatial navigation, energy requirements, and safety protocols. The final stage of this roadmap is considering the ethical and safety aspects. This involves the establishment of ethical guidelines for micro-wormhole research, taking into account potential risks, societal impacts, and responsible innovation. The development of safety protocols for micro-wormhole experiments is also crucial, considering potential hazards, risk mitigation, and emergency response. In summary, this roadmap provides a comprehensive approach to understanding and exploring the enigmatic world of quantum micro-wormholes. It starts with the development of a theoretical framework, followed by detection, manipulation, application, and finally the ethical and safety considerations. This journey through the labyrinth of quantum micro-wormholes is not just a leap into the unknown, but a stride towards the future of quantum physics and space exploration.